Assalamu alaikum viewers. Today we are going to solve Feb March 18 paper 1-2 AS Physics question 28. So let's begin. A tube of length L is open at both ends. A stationary wave is set up in this tube with a turning fork vibrating at a frequency of Fx is held at one end. So basically they are talking about this tube. Okay. And then this is the lowest frequency of the stationary wave that can be formed in this tube. Another tube of length 2L is closed at one end. The stationary wave is set up in this tube with a turning fork vibrating at a frequency of Fy is held at the open end. This is the lowest frequency of the stationary wave that can be formed in this tube. So now this is assume that the end correction for each tube is negligible. Which statement is correct? So basically you have to tell the relationship between x and fx, which is the lowest frequency possible in this tube. Okay. And then you have to end the fy, which is lowest frequency possible in this tube. So as this question belongs to the stationary waves, so you must be very clear that what are antinodes and nodes, right? So in tube that is open from both ends, so you must be knowing one more thing, yeah, that at open end always an antinode forms. Okay, and here is this node. This is the node. And in a closed tube, and yeah, at the closed end always an node forms. So in closed tube, the curve or the shape of the stationary waves with the lowest frequency looks like this, right? And you must be knowing that the distance between antinode and node is 1/4 lambda. So basically you have to find the value of L. L is equals to 1/2 lambda. Why? How? Because 1/4 lambda and 1/4 lambda. So 0.25 lambda plus 0.25 would give you 0.5, or which means 1/2 lambda. Understood how? Because see, the distance between antinode and node is 1/4 lambda. So this is technically 1/4 lambda. This is also technically 1/4 lambda. So when you add both to find the value of L in terms of lambda, because we have to find the frequency, so it would be 1/2 lambda. And for this one, as it's very clear that the distance between the node and the antinode is 1/4 lambda, so the value of 2L would be 1/4 lambda. So now let's see how we will solve this question, as I have already done the working for you. I will show you how you will solve this question. Okay, so sorry. Yeah, so for tube 1, as I told you before, that L is equals to 1/2 lambda, and for tube 2, L is equals to 1/4 lambda. So now to find lambda, you just shift the 2 here, so it becomes 2L is equals to lambda. Now remember, frequency is equals to speed. This V represents the speed upon lambda. Okay, and now this frequency is represented by Fx. So which this would be equal to speed upon 2L, as lambda is equals to 2L. Here 2L is equals to 1/4 lambda. So you would shift 4 here, so 8L would be equal to lambda. Now again, frequency is equals to speed upon lambda, and as lambda is equals to 8L, so Fy, which is the frequency is denoted by Fy, it would be equals to V upon 8L. Now I have to find the ratio, or the Fy in terms of Fx. So for that we would keep this term, which is the coefficient for Fy would be at x. So to find x, you would do Fx upon Fy. We have already found the value of in terms of V and L for a value of Fx and value of Fy. So you just simply divide them. I'll show you the step. You must be knowing about the keep change flip. So this would be V upon 2L into 8L upon V. So as this and this would get cancelled, this would also get cancelled with L. So this would be 1s are and 1s are, and this would be 4s are. So x is equals to 4, and now this means that fx is equals to 4fy. So let's see which option is this. Okay, so let's see which option is this. And it is, sorry for that. Yeah, so it is option D. So option D is the correct answer for question number 28. Thank you so much for watching. Still, if you have any doubt, any confusion, you may ask in the comment section below.